welcome everyone to Terraforming Azure Synapse Analytics, and I'm really happy to get to join the third Data Toboggan event. It's kind of fun to have a full day focusing on a single topic because we get to go so deep into many different aspects of that specific service. And Azure Synapse Analytics, well, there's many parts to it, so there's plenty to talk about for a full day, maybe even 2 or 3 or a whole weekend. So we'll be focusing now on kind of how do we automate the infrastructure layer of Azure Synapse Analytics and the creation of those resources. So if we think about Azure Synapse Analytics, this is of course a service that kind of comprises of multiple parts. To begin with, we actually need an Azure Data Lake storage to be even able to create a workspace. We need to have that. And then when we create a workspace, we get the serverless SQL pools. And then also, if we want to, we can create other pools as well. So the dedicated SQL pools, or then of course, the Spark pools as well. And then of course, for the integration side, what we have available are the pipelines as well. And those come out of the box as well when you create Azure Synapse Analytics Workspace. And of course, the ideal situation would be that we would have just a script or a button that we can press and all of this would just come up, because especially if we go towards more like production-like environments where we have networking configurations and we have a lot of role assignments, etc., it starts to get quite complex, and doing that manually then takes a lot of work. And especially if we want to kind of have duplicate environments, we want to have, for example, a dev environment and a production environment separately, then it gets tricky to make sure that those are in line. So of course, the first thing that comes to mind of how we could do this is using Azure ARM templates. And that is actually what is also mentioned if you go looking into the Git integration part of Azure Synapse Analytics, it would leverage ARM templates as well. The thing though is that authoring ARM templates is not that easy. It's not very easy to get started from scratch. As you see, there's like API versions and schemas and all these weird different fields that you need to set. And the structure isn't very simple. It's kind of hard to grasp. But yeah, technically we could have an ARM template and that could then create all our resources magically. But luckily, we also have some other options as well. We are not just restricted to ARM templates. And today we're going to be talking about one of them, and that is Terraform. And we will see kind of what are the benefits of using Terraform as well. And to get to Terraform, we're going to start off with looking at an introduction to infrastructure as code first. Then we're going to look at how you can get started with Terraform and how to start building that Azure Synapse Analytics environment. And then we are going to look at, well, how does this affect the way you work? If you start using Terraform to define your resources, how does it change everything? And how far can you get with Terraform as well when we're talking about Azure Synapse Analytics? What kind of resources can you create with it? So I'm Heini Ilmarinen. I work as a DevOps consultant for a company called Polar Squad here in Finland. And pretty much today's talk is about what I do maybe 40–50% of my work time. So it is something that I work with very frequently, and I work with Terraform a lot, so it is kind of one of my favorite tools to use for this purpose. I'm also a data platform MVP and a Microsoft certified trainer, so I run some trainings on the side as well. And I'm also one of the 3 hosts at Knee Deep in Tech podcast. My favorite topic is architecture, and today it's not going to be so much about architecture, but it's how do we automate that architecture part, so definitely related. And my background is actually in mathematics, so if anyone wants to have any math discussions, that's always possible as well. And you have also might have noticed that I'm a bit of a serial doodler as well. So let's get right to it and start with an introduction to infrastructure as code. And so kind of, I think the most simple way to think about infrastructure as code is to think of it as this file that you have where you define the settings for your resources. And then when you have that file that has the definitions of what kind of configuration your resource should have, Then you, for example, hand it to Azure, as is in this case, and that will actually then be the one that creates and manages these Azure resources. For example, your Azure Data Lake storage for your Azure Synapse Analytics workspace and any other resources that come in there. And so then by tweaking those configurations and settings that you have in your file, then you are able to also change the settings for your Azure Synapse Analytics workspace. And we have many options to do this, as I already mentioned. We can use ARM templates, that's one option. And nowadays we also have Bicep, which is also possible that you take an ARM template and transform it to Bicep. But you do need to know that you have to do some manual work to get it working well. But Bicep definitely has a more intuitive configuration language than ARM templates, so it will be easier to use. And behind the scenes, Bicep is translated into an ARM template and then handed to Azure. But then we also have third-party tools. So we have Terraform, which is what I'm going to be talking about today. And then we have, for example, one commonly used tool called Pulumi as well. And a lot of the times it is up to preference, whichever tool you like the best. I've used Terraform so much that if I start to use Bicep, I get confused with the Terraform commands and things like that for a bit before I realize, okay, I'm working with Bicep. Never mind, I need to use the right thing. So there's a lot of similarities between the different tools, and that can also make it a little difficult to move between the different tools because it's quite close. So what is common to all these tools is that there are kind of two factors in play. And one of them is that these are declarative. And what that means is that we are actually just stating the end result that we want to achieve. We're not telling that, hey, go and create this resource first and then that one and so forth. We're just saying, hey, this is the end result that we want to achieve. So we do not have to care about the order of things so much. So this is kind of what separates scripting languages like Azure CLI or PowerShell from pure infrastructure as code tooling. Because with scripting, you do need to specify like the specific order in which you need to create the things. First, you need to create, for example, the data lake storage, and then you have to create the Azure Synapse Analytics workspace, and then you can start to create the SQL pools. The other aspect here that is important is that it is idempotent, and that means that we can run that configuration file as many times as we'd like, and we always end with the same end result. So we do not have to handle situations where, for example, one of those resources already exists that you have in your configuration file. The language will take care of that and just realize, okay, it's there already, I do not have to actually recreate it. And this again differs from scripting, where we do need to handle those situations that when a resource actually already exists, we have to take care of that. So then why would you be wanting to move to infrastructure as code instead of scripting or going into the portal and clicking through things manually? Well, there are a few benefits that I, at least myself, have identified. And the first one of that is that we get some documentation out of the box if we're structuring our files in a reasonable way. But do note that sometimes it's said kind of that, well, infrastructure as code does all the documentation for you, but there are some visualization tools available that can help visualize the relationships in your configuration file, but it depends on the tool that you use, how good it actually is. So you might need to have some kind of overview pictures to help sort out what is related to what, but you do not have to make documentation of the specific settings because those are in your configuration files directly. The other benefit that is there is definitely repeatability, and I think this is a major one. So pretty much with infrastructure as code, it is easy to create identical environments just with specific settings changed in your scenario. So for example, if you really want to have identical environments for dev, test, and so forth, infrastructure as code makes that so much easier. It makes it very much easier to just have those environment specific variables, and then you just run these files with them. It it kind of also makes it easier to recover if you have an error situation. If all the creation of the infrastructure is automated, you can create it completely identically from scratch, for example. And also, if you get into error situation, you can create a identical environment and do the testing in there and figure out what's going on and what's wrong, and then kind of fix that in your real environment as well. So we just get all those benefits that we get from repeatability in general. We get them with infrastructure as code. Lastly, the one item here is that we are able to leverage version control. And once we're able to use version control, it makes it easier for us to work in teams on the configuration files. And it also makes it easier for us to revert back to a previous state. If we make some kind of change and suddenly everything breaks, then we're able to go back into the previous situation that we had in place and just run those configuration files again and revert our own environment back to that state. It also brings other benefits as well. So we are able to get that history of what kind of changes have been happening in our environment, as well as having version control makes it then easier to set up, for example, automated pipelines for creating your environment and making those changes in the future. So it definitely has a lot of benefits that we can gain, but of course there's a bit of a kind of a speed bump in the very beginning that we need to cross over to get really rolling. And so to understand how infrastructure as code works in Azure, let's take a quick look behind the scenes of Azure Resource Manager in general. So we always talk about Azure Resource Manager, and what that really means is that behind the scenes we have all these different resource providers for the different resources that are in Azure. So for the Azure Data Lake storage that we're creating, it's going to use the microstorage resource provider. Then there is, for example, one for SQL, Data Factory, Synapse, and so forth. So there are many of these resource providers available, and they define what is possible for their specific resource. And so then when we are working in the portal or using Azure CLI or PowerShell or anything like that, we are always actually communicating through the REST API of the Azure Resource Manager that then passes on those kind of parts that we're asking it to do to the appropriate resource providers. And in some cases also, there are these software development kits available that then communicate with the REST API, which is the case for Terraform as well. It doesn't communicate directly with the REST API. And we'll take a closer look at that in a moment. But due to this structure of the Azure Resource Manager, all these resources that you create, their configuration is even stored behind the scenes in this computer readable way. And you just call these APIs to change the state of these resources. And we can already find that in the portal when we go in and choose to export a template. And even if you were creating your Synapse Analytics workspace and you did it manually, you could go in after the fact and choose to export that template to use in your own environment instead. So that's what happens on the Azure side. And that is kind of setting up us to understand then how can we work on this with Terraform. So to get started with Terraform, we first, of course, need to understand how does it interact with the Azure Resource Manager and the different resource providers, etc. So I mentioned we have these SDKs available there with different programming languages. And so, well, you want to get started with Terraform on your own laptops. So what you're going to need in the very beginning is you need to have Azure CLI, or, well, you could also do this with PowerShell installed on your laptop. So Azure CLI, for example. And then in addition to that, you also need to have Terraform installed as well. But that's actually all you need. Then you can just create your first Terraform file, run the required steps that you need to do, and that will pass that Terraform file to Go SDK. So this uses the Golang behind the scenes. And then it also creates a state file here that then tracks what are you asking it to do and what is actually already existing in Azure. So that is how the Terraform then communicates with Azure and passes those kind of requests for, hey, create this resource, make this change, etc. That's how they get passed on to the Azure side. So then the question stands, well, why would we use Terraform instead of, for example, ARM templates or Bicep or anything like that? Well, the first reason is not entirely specific to Terraform, but Terraform does have an easier syntax than, for example, ARM templates. With Bicep, they're quite similar in complexity, so quite easy. In both cases, it's quite easy to pick up this language. It doesn't take a lot of time to get started, as you'll see in a moment. The other benefit with Terraform is that it supports many providers. So what that means is that Azure is just one of the providers that Terraform supports. It also supports Azure AD. And that is a kind of important fact to note that, for example, with ARM templates or with Bicep, you're not able to create users and groups in your Azure AD if you'd wish to do so. It's not supported because Azure AD is not technically an Azure resource that is in your subscription. So with Terraform, you're able to do that. But with Terraform, you're also able to, for example, create resources in AWS or GCP or even on on-premise platforms as well. So you're not just restricted to purely Azure resources. The other benefit of Terraform is that it provides very frequent updates. So there's a new version of the Azure provider about every 6 days, and there's always new features and capabilities shipped. So even new features come to Terraform quite quickly. The one thing to note is that Terraform doesn't support any preview features, and that is because it uses the Go SDK. And the thing is that features of Azure don't get published to the SDKs before they are publicly available. So you do need to keep that in mind. There's ways around that that you can work around, and you can handle it in a very smooth way as well. But it's just good to know that that is the fact that you aren't able to get any of those preview features with native Terraform syntax from the beginning. All right, so then I think we're ready to get into our first Terraform deployment. And what we're going to do is that we're going to create a resource group, and then we're going to create an Azure Data Lake storage to start with. And after that, we're going to get into the Synapse Analytics workspace part as well. And for us to be able to get started, we are first going to set the provider. That is the very first step. And then we're going to create the first resource. So let's just get to that. I have a folder ready. I don't have any files in here yet, but let's get started. So we're just going to create our first file. I'm just going to call that main.tf, and that is going to contain the resource definitions that we want to use. And actually, I want to at this point show you the Terraform documentation. So Terraform has really good documentation available for it. I have now the Synapse Workspace documentation open here, but this is under the Azure RM provider, as you can see here. And you can find this use provider snippet here in the corner very easily. So you can just go in here and copy this, and then we can take that into our file and just copy paste that over. And then the one thing to note is that within this Azure RM provider block, you need to have this features block where you can specify certain settings about your subscription and for specific Azure resources in there. But you can actually leave it empty in the beginning as well. It doesn't require to have any settings specified. So what this does is it points us to a specific provider. So in this case, the Azure RM, you can see that it is actually a HashiCorp provider. So Terraform is a HashiCorp product. And then we specify the version of that provider in here. because there can of course be differences between the different provider versions. There can be new capabilities coming in, or when some of the resource capabilities change behind the scenes or new things come in. So that is where we're going to start, but then of course we will probably want to create, for example, that resource group that we created. So we are going to create a resource block in here. And as you can see, it kind of gives me a full list of things that I can choose from. And if I had a lot of, I could kind of find some of my resources in the list as well, but it might make sense to just start typing a bit and then go to resource group, and there we find that one. So this is just specifying the resource type that we want to create, and then we need to give it a name within Terraform. So this is not necessarily your resource group name in Azure, but it is the resource name reference within Terraform itself. And then for a resource group, we know that we require a name. And so let's just type this in here, like for example, and then let's put in the location, Europe. And for resource groups, we don't necessarily need any other settings in there. So that's at the bare minimum, we could leave it at that. And so pretty much we already have our first Terraform configuration ready. And to get started, we do need to be logged into Azure. So I have already ran AZ login in here and logged in with my account. And when I now start to run the Terraform files, it will create those resources in the subscription that I have chosen when logging in. So then now to get started with Terraform itself, I am going to run Terraform init. And you always, the very first time you start to work in a specific folder with Terraform, you need to run this Terraform init. And if we look at the output here, we see that it is actually pulling the HashiCorp Azure RM provider and installing that. Well, installing that, but anyways. And you can now actually see that there's this .terraform file here, and it actually has that Azure RM provider in there. All right, so initialization done. And then if I want to see what kind of resources this would create, I can just run Terraform plan, and it is going to check, well, is there anything in my state file? So the state file was where it's going to hold what kind of resources have been created in Azure with Terraform up to that point. So it's just going to tell me that it wants to add one resource, and that one resource is the resource group. So if I actually then want to create that resource group, then I can just run Terraform, as actually the output there specifies for me as well. And the one thing to note is that the apply actually runs the Terraform plan step as well. So once you start to get comfortable, you don't necessarily have to separately run the Terraform plan. It actually shows you the same plan here as well, and then asks you to confirm that as well. So at that point, you would have the option to just abort and be like, oh no, I made a mistake, and make the adjustment and then go forward from there. All right, so that is going to take a moment for it to create the resource group, not long. And if I were now to go into my Azure subscription here and go look at the resource groups, and it always takes a little time to refresh in the Azure portal, which I normally don't have the patience to do. It will then show up that resource group, and since we didn't actually create any resources in there, it's still empty. But you saw that it didn't take us more than a few minutes to just put the provider in, put the first resource definition in, and then run the Terraform init, and then plan and apply. And we already have our first resource in there. And if I were to run the Terraform apply again, it would recognize that that resource group is already there, and it wouldn't actually do anything. All right, if we then get to the more Azure Synapse specific resources. Then, of course, the first thing that we're going to need before we create the Synapse workspace is the storage account. If we grab the storage from here and give it a name that we can use to reference it, then for the storage account, we're again going to need a name. I can just use this same pattern here. Then I am going to need the resource group name where the storage account is created. And now you can see it's already telling me like, hey, you might want to reference this resource group up here. So we are referencing the resource type and then dot and then the name that we gave it in here in Terraform. And now this time specifically what we want to grab the name. So we just reference that name for that resource group. And then even with the location, we can reference that same resource group. And instead we just point to the location of that resource group. And in that way we can make sure that we are creating our storage account in the same location as our resource group as well. For just nice kind of aesthetic purposes, I always like to align my equal signs. You can also run Terraform FMT, and that actually does the formatting for you. And then I'm just, because it's kind of makes no sense for you to watch me typing, I'm just going to pull some of the other settings that we need here. So we're just to put those ones. And since we want a data lake storage, this last setting is especially important because we want to have the HNS enabled, so the hierarchical namespace enabled in there as well. All right, and then we are going to also need a file system in there that we then tell the Synapse Analytics workspace to reference. And so I'll just pop that in there. So it's always the same kind of process. We choose the resource we want to create, we give it a name, we give the required variables in there, or any of the variables that we want to set for that specific resource. And so we put those in there. And at this point, I am going to also put in the actual Azure RM Synapse workspace resource as well, because it takes some time to create. So we might actually get a chance to see it get created. So I'm just going to pull that from there. And as you see, let's walk through this. We are choosing the Synapse workspace resource, giving it the name Synapse. And then I'm giving it a name, Synapse-Heini, and again, referencing the resource groups. And now, since we need to pass in the file system, we are referencing, again, this resource from above. So the resource type and the name that we gave it. And this time we need the ID. And then we have the SQL administrator logins. We'll talk about that in a moment, how to maybe better handle those than putting them in your code. Then I also decided to give the managed resource group name, since that is an optional parameter, but I wanted to add that in there. And then I also want to give the Azure AD admin. And for this one, actually, we need kind of this data block that we're going to reference. So here we start to see the flexibility of Terraform, because we can actually use these different data sources and providers that we have available there. So I have the reference there already, but I'm actually missing the data source. And I'll actually pop it up here in the top. And what this data source does, it grabs my current Azure credentials that I am logged in with in my command line. So it grabs those current credentials. And then here, when I'm setting the Azure AD admin, I can reference that data source. So I have the data.azure client config. So again, the resource type. So this is definitely kind of the Terraform resource type. I am choosing the current one, since that's the name that I gave it. And then it will pull the object ID and the tenant ID to those two different fields. And then I also added some tags in here to the Synapse Studio as well. So this could be my development environment, for example. So that's it. And since I added quite many resources at this point, I am just going to run TF plan here to check that did I make some maybe just typos or anything like that in the mix. And then I can, after that, put the Terraform apply to run, and then we can discuss a few things while that is running, because it will take quite a long time for it to be ready. But yeah, it seems this was pretty right, at least. It's not giving me any issues at the moment. So I am just going to run TF apply. And you can always see that when I am starting to run a TF plan or TF apply, it has this TF state lock that it creates here. And then in a moment, it will also have temporarily like a backup of the TF state file. So the state file, it will have kind of like, this was the previous state and this is now the current state. And then if there comes any issues, it is able to revert back. So it kind of comes and goes in the different phases there. But that's how Terraform handles the different changes, etc. All right, we will let that roll because, as said, the Synapse workspace takes a while to create. And while we leave it at that, it will just start creating the different storage accounts. And kind of, I said that in these infrastructure as code, we don't have to care so much about the order, but in one sense, we do have to care about the order a little bit. So for example, in the Synapse workspace, we have the reference to the resource group. So with this reference, then the Terraform will take care that the resource group is created beforehand, because we have this resource group reference here. And same with the data lake Gen 2 file system there as well. All right, so let's leave that there and just hop back into the presentation for a moment. And so we've set the provider and created the first resource. And the one thing that we started to notice there is that we started to have a bit of repetition in the names in our configuration files. So what we want to check next is how we are able to use variables. And we'll take a quick look at that. And even though this is still creating the resources in here, that's totally fine. We'll leave it there. Even if we make changes in the file while it's running, it's not going to disturb it in any way. So we might want to just do that separately. So in here, I'm going to create another file called variables. So whenever you're in a folder, Terraform will pull all the TF files that it finds and kind of combine them all together. So it doesn't matter that if you separate a single resource to a separate file in here, and it can even help you kind of get a bit more structure and figure out where things are. And so let's put in a variable here. And let's call it env name. And then we are going to be required to give it a default value if we wish to. And let's just give it this Synapse that I used there above. So I wouldn't necessarily need to give the variable value here if I wanted to instead hand it when I'm running this these files instead. So I would be able to pass them in there as well. And I could add a description here, etc. But I'll just put in the value right now. And now I see that, well, I have this Synapse Heini string in here as well. And now instead I could actually replace this with a reference to that variable, the env name variable. And well, with a storage account name, it's not so straightforward, but let's take this straightforward ones first. Here, since we just have that same string, we can just directly reference this env name variable there. So up here, the difference was that we want to do string interpolation. So we want to have that RG ahead of it, and then the variable name, and so forth. And with Terraform, what is also possible is that we have these all kinds of Terraform functions or expressions. And so what I could do in here is, instead of having just the direct reference to the variable name itself, I could have a replace function and then have for env name there. And then how this function works is that we give it the string that we want to replace and what we want it to replace with. So we can kind of use that same environment variable in many different places and just adjust it if need be and make any changes, etc. So anything that we're kind of starting to repeat in our configuration a lot, we should definitely move on to the variables, or any values that we want to be able to change for different runs that we are doing, those we should also replace in the variables. Then the one thing I want to talk about quickly is secrets. I unfortunately don't have the time to show how that is done in practice, but we would want to create an Azure Key Vault. We could do that with Terraform, and then we would want to place the secret in there and instead put a reference in here to the secret itself. And there's ways we can generate the secret. We could use this kind of random resource provider in Terraform that allows us to create random strings, or we could create the key vault separately and go put it in manually and then have the reference in here to the secret as well. So there's a few ways in which to handle that. But for our case here, that is totally fine. All right. So we are done. So we got 3 resources added, 0 changed, 0 destroyed. So if we now go into our resource group, our resources should show up here as they do. I'm able to open my Synapse workspace and go in here as well. And then I would be able to come in here and create any resources and so forth. One mistake I actually realized now that I did was that I should have also, while I created the Synapse workspace, created a firewall rule, because I didn't do that. Then when it tries to give my credentials the access to the Synapse workspace, it actually failed in that. But that's kind of one thing to know, that when you do things in the portal, certain things kind of happen behind the scenes, whereas then with using Terraform or any other infrastructure as code language, you need to know certain things, kind of what happens behind the scenes, and be able to do them in here. All right, so we have used variables, and then we have the last thing I want to say is that there is also a command called Terraform Destroy. So, well, once you have actually data in your Synapse Analytics workspace, you don't want to go ahead and just destroy it randomly. But while you're building these templates and building these files, you can kind of go back and forth, do your apply, and then destroy everything, and then come back from there as well. So you are able to kind of verify that everything works from scratch as well. I write destroy, then it's going to start checking what does it have to destroy in there, and then it will ask you also the confirmation of, like, do you actually want to destroy these resources from here. All right, so we'll leave that running in there. So pretty much kind of the main process with Terraform is you run the Terraform init the first time you are starting to play with Terraform in a specific folder. Then you run the Terraform plan. And then lastly, you run the Terraform apply to actually make your changes. And then if you want to destroy everything, you then run the Terraform destroy. So the last thing I want to look at briefly is how does our workflow then change when we're working with these kind of configuration files instead of scripts and the portal. So you can think about it in this way, that you've been kind of working on your laptop nicely with Terraform, and it starts to really come together, and you're able to kind of just able to create your entire resource with that one command of Terraform apply. You just run it and give the variables, and everything runs as sweet and dandy. The fact is that other people are going to start noticing it and be like, hey, I want to get in on this. It looks like it's working quite well. So to work with other people, we are going to have some place where we're going to hold these different files. And that would be some kind of central repository. And this could, of course, be like GitHub or GitLab or Azure DevOps or whatever Git tool, central repository tool you want to use. But then to be able to work with that central repository, you need to have Git installed on your own computer as well. So Git is always installed locally. And what I would do then in that folder that I'm working in is I would initiate it. So same kind of commands as with Terraform. And then I would add this remote address, and then I would be able to push my changes in there. And so when I'm working with other people then, is that I would want to actually create a branch for myself. And then I would also need to check out the branch. Creating the branch doesn't actually yet move you to work on that branch. So the checkout then takes you to that branch. And what a branch is that it actually creates like a copy of the files that you're working with for you. So then once you start working on that branch, it doesn't actually change the main or master branch that you made the branch from. And so then I, of course, want to make some changes. I'm going to create a new Terraform file. I'm going to add that to Git so that Git is aware of it. And then I'm going to make a commit message of what was the change that I made. And essentially that will just make those changes on my branch, not on the main branch that I started off from. And then when I'm ready with my changes, I would then go ahead and then push those changes to the central repository. And then while I'm doing that, then we want to do a pull request and check that are these changes also okay from others' perspective. And if there are any conflicts, we would resolve those. So if we think about this entire Terraform thing, what can we really do with it? So with Terraform, what we're able to configure with this in Azure Synapse Analytics is that, yeah, like we started with the Azure Synapse Analytics workspace, that's possible, plus the Azure Data Lake storage. And when we create the Synapse Analytics workspace, we also get the serverless SQL pool. So that's all fine. And we're able to create the dedicated SQL pool. And if we're going to need a Spark pool, that we're also able to create with Terraform as well. Of course, then the pipeline's capability is there when we create our Azure Synapse Analytics workspace, but actually with Terraform, we are not able to create the pipeline definitions. So to make sense of what is available, we would want to look at the documentation. And in this documentation, we are able to see on the left here the different resources that are available. And these are mostly like infrastructure level resources. We can create the integration runtimes, linked services, private endpoints, role assignments, Spark pools, etc., and things for the SQL pool and so forth. But there's nothing about pipeline definitions, etc. So the thing is that Terraform is for creating and managing that infrastructure layer, not for the artifacts within Synapse Analytics workspace itself. So that you need to keep in mind, and that is another topic of another talk. So that's it for today. We ran through what is the introduction to infrastructure as code, and we got kind of oriented. Then we looked at how to get started with Terraform, and then lastly, we looked at how the workflow changes when we work with Terraform. So thank you so much for joining. I hope you enjoyed it. If you have any questions, feel free to reach out on Twitter, and I really hope you learned something new today.